Hello friends, welcome back to our channel. So in today's session we'll see one more type of generative AI model, that is diffusion model. So in our previous session we have seen the complete introduction about the generative AI, and also we have seen different types of Gen AI. So in our previous session we have seen one type of Gen AI, that is a generative adversarial networks, and today we'll go with the second one, that is a diffusion model. Diffusion model. So we'll see how this diffusion model will be worked. So the main aim of this diffusion model is to generate realistic images. So similar to our GANs, okay, generative adversarial networks, it will also create images, or else music, or else video. So all these things will be created in this diffusion model. Okay, so example for this diffusion model is, so one example is dall-e, Mid-Journey, okay. Next is standard diffusion. So like that, there are a lot of GPTs available. So already in our previous session we have seen this dall-e in order to generate the images, particularly images. Okay, now how this diffusion model works? So it will be working in three steps. What are those steps? So the first one is a forward process. And the second one is a denoising process. And the third one, training. So this will be work on these three steps. So what is meant by forward processing? So mainly it will take the prompt as an input and it will generate the realistic images. So by reducing the noise step by step. So for that, so the first one is a forward process, denoising process, and the training process. So coming to the forward process, so it will take one image. Okay, it will take one image. So it will take one clean image. Clean image means a clear image. And after that, it will add some noise to the clean image. Okay, so add some noise. Okay, and then it will compare with the original image. And it repeats, adding noise multiple times. Okay, so first process, it will take one clean image and it will add some noise, so that the complete image will be, there will be some disturbance on that image, and the same process will be repeated multiple times. Maybe it may be 1,000 or 1,500 times. So what happens at the finally, the clean image will be totally becomes a noisy image. Okay, if the same noise being added to the image multiple times, after some iterations, that means after some additions, automatically that image, the clean image, will be converted to noisy image. For example, let us take one image. This is an image. Okay, this is an image. So let it be see. So this is the textual image. Okay, image consists of AB. First time it will add some noise. Second time it will add some more noise. Third time it will add some more noise. Fourth time, fifth time, sixth time, seventh time. See how it becomes after thousands of times. What becomes? The clean image will be converted into a noise image. For example, let us imagine this as a noise. Okay, so after 10 thousands of iterations, what happens? The first image is this one, and after thousands of iterations adding some noise, the image becomes this one. Okay, so this will be done in this forward process. So why it will be happening? So in the second step, it will start denoising the image. That means removing the noise. Removing the noise. Okay. So the first step is forward process, taking the clean image and converting the clean image to the noisy image. And the second step, so it takes noisy image, okay, it try to remove some noise from image, and then it will be repeatingly, I mean it will repeat the same step multiple times. Okay, so same thing. So repeatedly removes noise from image. So what happens? Finally we'll be getting noisy image becomes clean image. Noisy image becomes clean image. So this is called as a reverse process. So this is a forward process. So forward process means taking the clean image, converting it to noisy image. And coming to the denoisy process, that is a reverse process, taking the noisy image, complete noisy image, and slowly it was trying to remove the noise from the image, and repeatedly after thousands of times, multiple times, so noisy image will becomes the realistic image, a clean image. So this is the process. Okay, so finally this diffusion model will be learning how to predict the noise and how to remove that noise from the image, so that it learns from these two things. So simply to understand, it will learn how to convert a blurred image to the clean image. So blurred image means there will be some noise. Okay, so by using these two processes, it will be learning how to remove the noise from the image. Okay, so training or generation of image, first it will take random noise. Random noise. Okay, random noise means, for example, let us explain about this one. So if the image is in this way, so A, B, and if it is completely with a noise, okay, if it is a completely with this noise, see, this is the thing happens here. So what happens? This is the input for a denoising process. Slowly it will be starting removing the noise. For example, in the next step, it will be in this way. See, it will be in this way. So it removes some noise. So this portion, okay, this portion, it removes the noise. Yeah, afterwards it will be removing some other noise, okay, some more noise. So for example, let us take this one. So let us take this one. This is a thing. See, some noise is again removed. So after that one, in the next step, some more noise will be removed. So like that, after multiple tough times, clean image, we will be getting the clean image. Now how it generates, how it generate means, it will take the random noise. So let us take the random noise. So this is a random noise. Okay, so complete, the image is full of noise. Okay, full of noise. So this is a full of noise. And what happens? Slowly, step by step, it will start removing, it will start removing noise from image. Okay, slowly from this image, some noise will be removed. Okay, some noise will be removed. Okay, so after that, after repeatedly, so what it have learned from the two steps, that means a forward process and the reverse process. So it learned how to remove the noise. Okay, from these two steps it will be learning how to remove the noise from the noisy image. So based upon that one, it will remove the noise from the image and it will generate the realistic image until it gets the realistic image, generating realistic image. So this is be done in the diffusion model. So these steps will be continuously processed. So very fast it will be processed. So what we are saying, this diffusion model is to generate the realistic images. How it will be generating the realistic images means it will start removing the noise from the image. Okay, it will start with the random noise, and from the random noise it will be slowly removing the noise to make the image realistic until the image gets a realistic image. Okay, so this is the steps involved in the diffusion model and how the new image will be generated in diffusion model. So example, dall-e is an example, Midjourney is an example. So in order to generate the images or audio or video, so we can use this diffusion model. So now I hope you understood how it will be generating. Now, what are the advantages? So obviously advantages, so it will give better quality images, better quality images, and one more thing, it will convert low resolution images to high resolution images. So another one, right? And it will have a stable training. The training of data will be a stable in this. Okay, stable training. And one disadvantage of using this diffusion model is, so it consumes more power, requires more computational power. So why we are saying this computational power means, so we are in theoretical way we are discussing that, so it will start adding the noise and it will start removing the noise. Here the noise is Gaussian noise, which is in a mathematical formula, so that will be applied. So there will be a lot of computation power, it requires a lot of computational power, and also it is a slow process. So when compared to other, so it is a somewhat slow to generate the images or a music or a video. Okay, and applications. So we know the applications, a lot of applications. So one is mainly to create 3D models, 3D models. Similarly, image, text to image, and image processing. It will be used for image editing. Okay, image editing or image processing. Okay, in order to smoothness, I mean give the smoothness for the image, in order to change the blurriness of the image. So image editing will be there. Similarly, text to video, it will also be generating the videos, animated videos. So all these are the different applications. One major application is creating the 3D models. Okay, so this is how the diffusion model works to generate the images. So once again I'm repeating the definition. So it will be generating the realistic images by removing the noise from the images. Okay, so I'll stop here and hope you understood this one. So if you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.